I'm very glad to meet again Dr. Nicholas, or how we call him, Nick Hankins. That's how he is addressed usually, Hankins. He is from the Oxford University, a fellow of the late Margaret Hall. Maybe when we have time, we will explain you how Oxford University works. It's quite different from our university system. They have colleges and departments, and you belong to a college and a department and so on. It's a quite complex system, but very, very interesting, because in the same college you have researchers and professors and fellows from almost all subjects, which enhances a lot the talkings and the understanding of science. He is from the Department of Engineering Science, and this is another interesting thing over there, is that they have a department that takes care of all the engineering sciences. And so again, in one department, we will meet with people from electronics and people from chemistry or mechanical engineering. Professor Hankins is a chemical engineer, if I remember. And we have met about 10 years ago when we start some talkings about wastewater treatment using membrane technology, that he was an expert on this at that time. And a very friendly person that put together Palestinians, Arabians, and Israelis talking together for on the subject of water sustainability, water treatment, membrane use, and so on. So, and I was quite impressed in a conference in a room with all these people that in their land they are enemies fighting each other, and in that environment they were talking quite friendly and for one purpose, that was to have water. So I think with this introduction we can start the lecture. We will have a lecture until up to about 10 something, then we will have a coffee break and come back again. Thanks.
Okay, thank you very much, Professor Eduardo. It's a great pleasure to be back here in Brazil. I've been here dozens of times. I've lost count of the number of times, but it's always a pleasure to be back in such a sunny, friendly, cheerful country. I know there's some problems here, but it's still worth coming. Yes, so as Eduardo mentioned, we first met about 10 or 11 years ago when Professor Eduardo was doing his postdoctoral work, and he was working with a colleague of mine called René Barneres Alcantara, who's from Mexico. And it turned out that both Eduardo and I had a big interest in water engineering, so we started to talk about projects. And we did actually have a collaborative project that was funded by, was it CAPES or by FAPESP? I think it was FAPESP, which finished about a year ago. So some of you may remember I came here to give a plenary lecture. And I will be doing the same thing this evening, so I hope to see you. But the idea today is to have something a little bit more informal. So rather than think about this as a class, it's more like a tutorial. In Oxford, we have a tutorial system, which is where the tutor, which is me, sometimes I wear a black gown, it's very medieval, and I have just 2 or 3 students in the room, and I can tell you that not one of those students falls asleep or gets away with doing nothing, and I expect the same of you. So don't be shy. You're not just here to sit and listen to me. You're going to be doing some of the work as well, and I'm going to be maybe asking you some questions or getting you to ask me some questions, but I want you to feel at home. Well, it is your home, I'm at home, so we should be very, very comfortable and we can have a good discussion. So let me introduce you a little bit to Oxford. I did have a lot of nice pictures of Oxford, and I'll try to see if I can find them after the break. But first of all, let me introduce to you the Department of Engineering Science. So we are one of the largest, if not the largest, integrated department in the United Kingdom, along with Cambridge University. So Cambridge University also has an integrated Department of Engineering, which means that it's not just one discipline, but it's all of the different disciplines put together. So we have mechanical, civil, electrical, etc., many, many different disciplines. And that's really very nice because it means that if you're trying to work on a particular research project and you have problems that you can't solve, you may be able to find a colleague who can solve them for you. So you can work together. And really, we shouldn't think in boxes. This is a very almost Victorian way of looking at science and engineering in disciplines. Of course, we can't be experts in everything, but we can all be experts in our field and bring those things together to enable bigger things to happen. So really, we try to be collaborative, but we cross all of the disciplines of engineering, which is quite powerful. So as well as being the largest, or one of the largest in the UK, we were recently ranked #1 in the world. So this was done by various agencies. In particular, the Times newspaper in London do a ranking exercise, which is based on research income, number of students. They do a survey of how happy they are, how well employed they are, etc. And it seems to be doing quite well. But I'm not here to brag. You know why I'm here. One of the things that we're particularly good at in Oxford is IP generation and technology transfer. And I think this is something that's only just started to happen here in Brazil. But the idea is that you take ideas from research and you write patents, you generate IP, which is information, property, patents, and so on, royalties. And then you transfer the technology out into the market. And that means that you form small companies. And what I can tell you is that recently I got involved in starting a small company myself, which is based on some technology that I'll be talking about later in the day, which has to do with the recovery of metal ions, heavy metal ions, from waste waters. Some of those metal ions, they're not just waste, they are extremely valuable. So things like iron and copper can be recovered from mining streams. You have very big mines here in Minas Gerais, I think. There was yet another disaster recently. We chatted about Sebastian here. But also, if you're manufacturing things like catalysts, you have precious metals. So platinum group metals are very valuable, and these can be recovered from streams. So I've started a company which allows us to do that, and we're talking to very big companies to market that technology. So this chap on the left, this is Fruin Jenkin. He was the gentleman who, in 1908, which is when Eduardo came, I think you remember, we had our centenary celebrations. It was very grand. We had a lot of garden parties, and I think we shared a glass of champagne at one point. But he was the first ever professor of engineering science at Oxford. Turns out that his grandson became a very famous politician, Patrick Jenkin. You can look him up on the internet. You've probably not heard of him. But he was the Home Secretary of Britain, which is a very important political position. And his son is now a very important MP involved in Brexiteer. He's a Brexiteer, which I'm not. So we could talk about Brexit all morning, but I don't think we will. We do a lot of things at Oxford. There's a very wide range of activity. It's one of the great strengths. So everything from jet engines. So we have a collaborative arrangement with Rolls-Royce, and we research new types of jet engines to make them more efficient. I think they have some connection with Embraer here in Brazil. There's me in the middle working on water. So there's a number of us who are looking at water treatment, water recycle, and so on. And here we do work on information technologies. So we have a department of robotics, people looking at the development of robots and artificial intelligence. In this particular case, it's computer vision. So how do robots see the world? They need to be able to perceive the world in a certain way, and it all comes down to geometry and the computer visualization of images that can be interpreted by a robot's brain. We also do a lot of work in biomedical engineering, so things like artificial organs and that kind of thing. So a lot of things going on in Oxford. If you have the chance to do a postdoc, I can recommend it. I think you'll like it. So we're quite a big department. This slide's probably a little bit out of date, but it gives you an idea of the size. So we have about 90 professors and lecturers, including myself. We also have research fellows. So Eduardo was mentioning that we have colleges, and the colleges appoint research fellows who are a little bit like faculty, but appointed just for a fixed period of 2 or 3 years. And we also have quite a lot of postdoctoral researchers, but maybe not as many as you do. We have lots of workshops, technicians, support staff, administrative staff, and this number is probably a bit low now. We have about 200 or 300 graduate students. People who do PhDs at Oxford, we call them DPhil. So rather than PhD, it's a DPhil, but I think it means the same thing. We have £7 or £8 million a year of research funding and quite a big turnover as well. You have to multiply that by 5 to go into reales. And about 650 undergraduate students. And the way that it works is the university is really made up of about 40, 45 colleges. So if you're an undergraduate student and you want to apply to Oxford, what you do is you apply to a college. And then you will go to that college. If you're lucky, you'll go to that college and have an interview. And that means that you need to have very, very good grades, that your teachers write very good things about you. And you'll end up sitting on a desk opposite me, and I'm going to ask you some very, very hard questions about calculus and geometry and Ohm's law, something like that. And if you're good, I might take you. And then you'll become one of the 6 students that we take in each college. 6 times 30 or 40, that gives us about 200. So we have about 200 come in each year to do our undergraduate degree. Now, at that stage, I'd like to ask you if you have any questions about Oxford University that you're dying to ask. Feel free, even if it's a silly one. And by the way, we lost the boat race again, but the person who was the president of the boat race was my tutee. And the reason we lost is because I made him work too hard on my tutorial problems. So you can blame it on me. Any questions?
I was explaining
the boat race. We do a lot of work on Spinout. So Spinout is really the formation of technology companies that are based on research that's done in the department. This article's a little bit old, I'm sorry, but it's just a slide I happen to have. But I think it makes the point that that university companies are now investing quite a lot in technology. So I'm not sure how important this is now in Brazil, but I think it's definitely the way forward for you. You need to do that. It's what we call the third way: teaching, research, technology. So what I'd like to do to start the session this morning is to talk about some metrics for sustainability. So we hear a lot about sustainability. I'd like to talk in some more detail about what we really mean by sustainability, and importantly, how do we measure it? Because we're engineers. Engineers are quite unique in the sense that we have very good quantitative skills in which to analyze and to measure the world, and therefore to redesign the world in a way that's not just useful to us, but it's useful to the planet. And really, to do sustainability properly, we need to have ways to measure how effective that design has been. So we need to have metrics. Now, this picture on the right's a little bit dark, but can anyone tell me where that is? You have to look carefully. Any guesses? It's not in the Western Hemisphere. The clue is, if you look here, you can see there are buildings coming straight out of the water. Venezia, yeah, it's Venice. So Venice has a problem because it's sinking into the lagoon in which it's built. And that's partly because the level of the lagoon is rising because of so much shipping in there, but also because Venice is built on very weak foundations of mud and soil and rock, which is slowly sinking. And if you put on your diving suit and go swimming around, you'll see that the whole of this city is built on these wooden scaffolding, which was built probably in medieval times, and it's slowly collapsing. So there's a very serious problem that Venice was never built in a sustainable way. So we need a way to measure that. That's why we're going to do metrics. I want to start with a statement from the Brundtland Report. Now, I can recommend that you try to read this because it's a very important state of the art as far as sustainability goes. But this is the key statement that he makes. The definition of sustainable development, it's one which meets the needs of the present without compromising the ability of future generations to meet their own needs. In other words, we have to look after the needs of our generation, but we shouldn't do that in such a way that it will compromise the ability of future generations to do that for themselves. So think about your children and grandchildren and great-grandchildren, how what you do now is going to affect them in time to come. Because if we only think about our own needs, there may be no planet left by the time they come along. So really that's the idea of sustainability is being able to go on forever, not just for the next day and the next day, but creating solutions to the problems that can keep being solutions in a very long term. So some of the key outputs from the report conclude we need all of the following. We need international cooperation. We need to work together because the problems are not just national, they're international, they're global. Because what one country does has an effect on all the other countries. So if you take global climate change, who's to blame for global climate change? It's not me, it's not you, it's everyone. So we need to work together on an international level. We need to improve the quality of life for the current global population, and that's what we're trying to do when we think about sanitation and clean water and so on. And it's certainly not equal around the planet. So some countries have it good, some countries, particularly sub-Saharan Africa, who have a rough deal. So quality of life is not equal, but we try to make that better for the current population. We need to live within our means, so live within the current carrying capacity of the planet. So someone did some calculations. If we all lived like people do in the USA, or maybe even here, I don't know, but if we all lived in this very advanced way, we'd need about 5 planets. So obviously we benefit from this luxurious but rather excessive and wasteful lifestyle, but we can't all do that. It's not sustainable. So we have to live within the capacity of the planet. And we have to make sure that the world's going to be better for future generations. So that's really going back to the first point, that we have to think not just about the present, but about the future. And that's intergenerational equity. Let's be fair, not just in space, but be fair in time. Think about being fair to future generations, be considerate to those people when they come after us. What are the water problems? Pretty damn big, I would say. This is some information from a report that was written by WaterAid. WaterAid's a UK charity that looks after water poverty around the world. But I think that there's pretty wide agreement on this. At the moment, there's 1.1, maybe even more, maybe 1.2 or 1.3 billion people who don't have access to safe water, so water that's neither clean nor free of contaminants, not fit to really drink or consume. It's going to cause disease and problems. And even worse, there's about 2.6 who don't have access to proper sanitation. And again, many of those, unfortunately, are in sub-Saharan Africa. So the tragedy is that every year, there's about 2.2 million deaths occurring related to these issues of water. I think Mario talks about the nexus of water and hygiene and sanitation. Even more tragically, many of these are kids under the age of 5 who are obviously susceptible to these diseases that are caused. So, terrible tragedy going on in the world right now, which of course we're all here, we know about that. But even in developed countries like the United Kingdom, we suffer from water poverty. So that means that even there are people who are affected by water poverty. They don't have access to running water, or they can't afford to pay their water bills. So we kind of take water for granted, but water costs money. You have to build treatment plants, you have to use chemicals, you have to treat it. And it's not straightforward. Can anyone give me an estimate of how much does it cost to buy municipal water here in Brazil? If you have a water bill and you pay for, say, a cubic meter of water, how much does that cost? Anyone got any idea? Does anyone pay bills? You must pay bills. 3.5 reals. So that would be, in UK money, about 60 pence. Okay. So we pay about £1, so that's actually comparable. And do you pay the same cost for water in and water out? So you pay for water supply as well as sanitation. It's about the same. So you pay about double. And how much? So do you know how much water does each person consume per day, roughly? Any ideas? How many? 200. Yeah. That's pretty much an average for developed countries. So about 200 liters a day. It's a lot, isn't it? 0.2 cubic meters. How much of that water do you actually drink? How much goes straight down the tap? Exactly. So we flush it down the toilet, we sit under the shower, we have a bath, we clean our cars. Do we really need such clean water to do those jobs? Well, in Australia, they already have a problem of clean water supply. They don't use, they have two supplies. One is water they can drink, and the other one is water they can use for showers and cars, which is obviously not as clean. But this is the way you have to go when you're short of water. They've had a drought there for 10 years. And that's where it's going to go in other countries if we have climate change. So really, we waste a lot of water, and this is a big issue. But we're lucky because we have the water to waste, and some countries don't. Marin? So let's think about what does sustainability really mean? What do we mean by sustainable development? Well, I would like to think that sustainable development is a route towards the complete sustainability of human activity, because that's what we're concerned about. It's what we do as humans on the planet. It doesn't matter. We're not worried about what whales do or elephants or insects. They seem to have been living sustainably for the last hundreds of millions of years. But we came along about 50,000 years ago, and things are getting a little bit tense. When we talk about sustainability, there are three things we have to consider. We have to consider economics, and economics has always been the thing that human beings are worried about. Can I afford this? Do I have the money to make this? Is this going to work? This is always the first thing we worry about. But what we need to worry about is the effect of what we do on the environment and on society. So do our activities have a negative impact on the environment, and how do we measure that? What about on the effect on society? So is what we do fair to all members of society? Do we benefit and someone else loses out? When you think about international business, you feel that some countries do very well out of it, and some very poor people in other countries do very badly. Think about coffee manufacture, not just in Brazil, but countries in Africa, countries in Central America. Seems as if a lot of people get exploited, so a few people make a lot of money. So these kind of things are important. We have to think about what's sustainable to society. And if something is really sustainable, then what we want to make sure is that all of these things come together. So this is a thing called a Venn diagram. Have you ever seen these before? Do you remember Venn diagrams? So there's a kind of Boolean algebra that allows you to calculate what the overlap is, or what the intersection is, or what the whole set is. But this is the intersection of all three. And you can see you want that intersection to be as big as possible. All those three rings should come together. But actually what happens is they fall apart. So usually the forces that control these different aspects are controlled by different groups. So the guys who are worried about environment might be Friends of the Earth or Greenpeace or is it Sebastian Salgado, someone like that. But you have economics. Who runs the economics? Well, that's going to be the people who run the very big companies, the company directors, or maybe the government, the treasury of the government, the president. They're thinking about money. Do they really think about these things? Well, they should do, but maybe they don't. And this is me and you. This is what affects us, society, people. And we need to bring these together. So it's a major job, and it's not just a job for engineers. Engineers are very good at the economics thing because we know how to design things and build things that run in an efficient and an inexpensive way. But that's not the whole story. So I encourage you as engineers to put sustainability into your thinking, that when you design things, it's not just a technical achievement. That's a difficult one, I know. But you have to think about what you do in terms of the environment. Is the thing that you designed friendly to the environment, the materials that you need, the raw materials, the products? Can you do it in a better way so it won't be so environmentally damaging? Is it going to be fair to society? Is it going to employ people? Is it going to keep people safe and employed and secure? There are things you can do to ensure that. Now, we can do things in many different ways, but the question is, can we tell whether one particular policy, one particular project, one particular product is more sustainable than another one? And that's really why we want to use sustainability metrics. So I'm going to talk to you a little bit about that. So I'd like to introduce to you this gentleman here. This is Baron Kelvin, William Thomson Kelvin, a very famous, he was Scottish actually, British scientist who was a fellow of the Royal Society and also who was a fellow at the University of Cambridge. Kelvin was a very clever chap. He was very, very bright. Probably best known for the temperature scale, but he did many, many different things in the field of physics. And what he realized is that if you want to measure something, you need numbers to do that. Okay, so we can all argue about left versus right, how this compares to that. But there's only one sure way to compare things, and that's by having a quantification. So if you have a football match, the best team is the one who scores the most goals, right? Well, it's something that you can't argue with because you can measure it. So what he said was, I often say that when you can measure what you are speaking about and express it in numbers, you know something about it. But when you cannot measure it, when you cannot express it in numbers, your knowledge is of a meager and unsatisfactory kind. So in other words, you have to be able to measure things to determine what they are and how you can compare those with something else. And that's really what we're trying to do with sustainability metrics. So you need to be able to measure things in terms of numbers. Let's have a look. So we can choose metrics both local and global. Now I'm a chemical engineer, and I even spent some of my career working for Shell. So Shell, as you know, is a very large petroleum company. It's based in Holland, but it's actually a joint UK and Dutch company with offices in both London and The Hague. And they have some very, very big refineries. So this particular refinery is in Stanlow, which is in the northwest of England, near to the city of Chester. Some of you may know Chester. And it's a very, very big refinery complex. Supposing you're trying to measure and understand what's going on in that refinery. Well, it's a very, very complex process, and you literally need hundreds of measurements. So what you would measure, for instance, you have a stream, you'd measure the temperature, the pressure, the flow rate, and so on. And if you want to control it safely and efficiently, you have to measure all of them. So each one is a kind of indicator of local performance. Now, that's one thing, because that gives us a very detailed overview. But on the other hand, we can measure an overall performance. What's the bottom line? So how well is this refinery actually working? And the idea is that the overall performance can be represented in terms of just a few key indicators. So what's the yield of gasoline per ton of feedstock? So that's one thing we can measure. That's a good metric. It's an economic one. Or the profit, what's the bucks per day? How many dollars per day or pounds per day do we actually create in terms of profit? So either one of these is valid, but you'll see that these are local ones because they're very detailed and refined ones. And these are global ones. So this is the big picture, really. This is the overall message, and this is what contributes to it. And we need both, really. We need to understand the details so that we can understand the bigger picture. But for all of these, we need numbers. And as engineers, we measure things. We have instruments to measure temperature, thermometers, we can measure pressure gauges, we can measure flow rates. So how do we go about choosing the kinds of measurements that we would like to make? What are the requirements for the metrics? Well, the first thing is that it must be relevant to the defined purpose. So if we're trying to measure, for instance, the environmental impact of a project, how do we measure that? Then we have to think about something in which that process may affect the environment. So is there a toxic release to the atmosphere? What's the concentration of that toxic material? What effect will that have on the wildlife? Will it kill things? Or what effect will it have on rivers? Will it kill fish? Will it affect the fish? It needs to be relevant to the defined purpose. So the first thing you need to do is to think about what the purpose is. And then you can start to think about the variables and their relevance. Second thing is, what kind of data do we have available? There's a lot of things that we can measure. Some of them may be more difficult than others. But they have to be available, and they have to be quantifiable data, empirical or otherwise, but they have to be quantifiable. We have to be able to measure them. What we don't want is qualitative judgments. What we don't want to say is, oh yeah, this plant is bad because it puts out this gas, but so what, you know? How toxic is that gas? What kind of effects is it going to have? So it has to be quantitative, not qualitative. This is the only way that we can have a fair judgment. Third thing is we need to have wide coverage. So all of the key aspects need to be included. We can't cherry pick, and this is where politics comes in, because if politicians get involved, they'll cherry pick the issues, or let's look at what's good. We'll take the variables that look good, but ignore the ones that are actually bad. And we can't do that. We have to be objective. We have to cover all of the aspects. At the same time, though, let's try to make the job as simple as we can. Avoid too much duplication, avoid needless complexity, so keep it. There's going to be redundancy. We may end up measuring the same thing in different ways. We may measure a temperature here, may measure a pressure there, a flow rate somewhere else. They may actually overlap to some extent. We can develop composites. So that is to say, you're trying to measure the impact of a particular variable, but it may have effects in different places, and those effects may vary depending on their importance. So the idea is that you weight them. I'm going to give you an example in a minute of how we weight the impact of a water project. But we can develop composites, which are variables that are really the sum, the weighted sum of a number of variables that will give us an overall variable to calculate the impact. So examples of that might be things like the consumer price index, which is very much a composite index, or the price to earnings ratio, where both of those are really composites that have been put together. And I'll take you back to good old Lord Kelvin. A set of metrics which is not planned for some defined purposes is merely a collection of statistics. So we're not interested in gathering statistics. What we want here is to collect a useful set of metrics with a defined purpose. So that's the message here. This is the take-home message, that we need to measure things. And we need to know what we're trying to measure, and we need to then choose what we will measure. So these are the requirements. I'll give you an example. This is a thing called the Human Development Index, which is an index that's used around the world. And this is a composite index. So the way that we calculate this is that we take the current value, the actual value, and subtract the minimum value and divide that by the range, so maximum value minus minimum value. So as an example, let's look at life expectancy. So these are probably to some extent arbitrary, but they're used by the United Nations. So maximum value is typically chosen as 85. A minimum value is 25. Now some individuals die at birth, so that's not obviously always true. But this is just a sort of a standard that's used. And similarly here, we look at adult literacy rate. So we assume that ranges from 100% in a very advanced society to 0%, where no one can read or write. We also look at combined gross enrollment ratios. So this is how many people are actually signed into education. And again, that's going from 100 to 0. And finally here, I've got GDP. That stands for gross domestic product per capita, per person, which is measured per person in US dollars. And again, somewhat arbitrarily, we're going from 40,000. So that might be a fairly wealthy country like the USA or Switzerland, down to 100, which might be somewhere like Niger in sub-Saharan Africa. And then what we do is we combine these. So we use a weighting for these two. That's 2/3 and 1/3, and this, and put those together, and that gives us an index. Now, I make a note here, which is that income is adjusted because achieving a respectable level of income does not require unlimited income. So in other words, how much money do you really need to be well off? I mean, you can be a billionaire. In fact, most billionaires I've heard of are greedy. They think they don't have enough money, people like Donald Trump, you know. But really, how much money do you need? I mean, you can live comfortably for $40,000 a year. If you can't, then it's your problem. But for that, we tend to use the logarithm of income. And then we calculate the HDI, which is the average value of the three indices. So let's go to the... So here's a plot then of how HDI has been changing over the years. This was a graph that was produced by the United Nations. Okay, the numbers are a little bit old, so I apologize for that, but you can extrapolate. But you can see here, I've chosen 2 European countries. So there's the UK and there's Norway. So Norway is generally considered to be the most developed or wealthy, better off country in Europe, mainly because it discovered large oil reserves in the 1960s, and it's still doing well from that, unlike the UK, which did very badly. But anyway, you can see that in both countries, the HDI has gone up, started at 0.85, and it's now 0.95. So we're doing pretty well in terms of, you know, life standard, really. But then you compare that to other countries like Russia. So Russia went through quite a big dip when the Soviet Union collapsed, and it's only just really recovering. But of course, we know that Russia's now a kind of mafia state run by a megalomaniac KGB lunatic. That's politics. It's only just started to recover. China, which has been undergoing a very slow but steady development, political development over the last 30 years as it emerges from a very controlled system to essentially a capitalist one, but with a communist control, is doing very well. You can see that it's rising up very steadily. So if we don't think about human rights issues, I think China's doing pretty well. But look at this, down at the bottom, struggling to even get to 30% is the country of Niger. So you can see that there's very big inequalities in the standard of life around the planet. But this is just an example of a metric that we can use to quantify something which at first sight appears qualitative, but actually can be very, very quantitative. So the HDI is really a composite metric. It's used by the United Nations Development Programme, and it's based on statistics for life expectancy, education, and income. So we look at those three things together to see how well people are doing. Now, we're going to see an interesting correlation in a minute. So in a minute, I'm going to show you some statistics for water poverty. But first of all, I'd like to define for you what water poverty is. So water poverty, or water poverty index, is another composite index which is based on a number of metrics. So here I've got 1, 2, 3, 4, I've got 5 different metrics. We're talking about water, yeah? So first of all, let's think about water as a resource. So how available is water in terms of surface water? Do we have rivers? Do we have reservoirs? Do we have groundwater that we can access to use? What about access to the safe water? So how clean is that water? Or how clean can we make it? What kind of sanitation systems do we have in place to treat it or to treat the waste from it? What about irrigation systems that we can use for farmland? So these are important things because no use just having raw water, but you've got to treat it and you've got to use it in an appropriate way. And then we come to capacity. And capacity is a lot about money. We need money to enable the purchase of the equipment. We need to educate the people who are going to use it. Okay, not everybody knows how to operate water treatment plants or even how to operate a small, maybe an ion exchange system at home or something like that. So actually, you have to empower people to use the technology. And this requires not only purchasing, but education. You have to educate people on how to use water and how to use it safely. And also, to some extent, lobbying. So this is really dealing with politicians. And politicians always crop up in these things. But politicians are actually useful when they're actually doing their job properly because they can make these things happen. So we have to empower people through the government to give them the capacity to use these resources. And then we have issues of use, so what kind of use we want to put the water to. And that may be for people, domestic use, but it may also be agriculture or industry. So there's different kinds of uses, and that will have an effect on the availability of the water. Finally, what about the environmental issues? So this may be related to the local aqueous ecosystem. So how fit is that water to use in the first place? But if we put it back into the environment, how clean do we have to make it? What effect will that have on the environment when we return it? We should think about that. But obviously, in some countries, they just need the water, and they're not so concerned about what they do with it when they're finished with it. But of course, that has a negative consequence because it creates a feedback. So nobody can really escape from the environmental issue. So what we do then is we take numbers for all of these metrics, these 5 metrics, and then we introduce a weighting. So you see here, I have WR, I have WA, and so on. We multiply the metrics, and then we normalize the term so that we can come up with a composite index. And I can now calculate that composite index for various countries around the world, and I'm going to do that in the next slide. So here we have a map of water poverty index around the world. Now this is color-coded, and fairly obviously we start off with nice neutral colors like blue. So blue is where there's very low water poverty. In this case, the factor is less than about 70%. Sorry, more than 70%. So really, it's not water poverty, it's water wealth. And then you start to increase the temperature. You go to orange, where you're sort of 60 to 70, and then the yellows are 56 to 60, and then the greens, where it gets to be quite high. And the red is danger, obviously. That's very, very severe. So the thing that stands out in that map, I think, is Africa, because just about all of sub-Saharan Africa is water poor. In fact, they've just had a very serious drought in Cape Town in South Africa where water supply just ran out. They had no more water. I don't know what they did, but they were in very serious trouble for quite a few months. So you see that the water poor areas in the world are all here, Sub-Saharan Africa, but also the Middle East. So you have the north coast of Africa, the Middle East, and then moving out here into South Asia and Far East Asia, so all of China, Mongolia, down into Burma. You can see Cambodia, parts of, this is Papua New Guinea, I think. And then even Australia is suffering, so we mentioned that. But on the other hand, Europe and the Northern Hemisphere, so Canada, the UK, Scandinavia, are doing quite well. Where's Brazil on this map? Well, Brazil is yellow, so it's medium. So you have a lot of rain, you're not short of water, but you don't necessarily have the means to treat it or dispose of it. So there are water poverty issues, obviously, here in Brazil. But that gives you an idea of the state of play across the world. And you can see that it's a serious problem. There's a lot of the world which is basically water poor. And I remember when we had the joint symposium with the Palestinians and the Israelis, and there's one gentleman who was talking about the possibility that in the future we may even fight wars because of water shortage. So what happens if all of these people up their sticks and say, right, we're going to walk into Europe and take their water, and how are we going to stop them? You know. So we're going to... Sorry?
There is an old film, a movie
Yeah.
about this.
Yeah.
It's a very interesting
I think that we were talking about Palestinians and the Israelis, and there has even been some...
about people from the Sub-Sahara going up to Europe by geography,
Yeah.
invasion of Europe.
So there you have it. There's a movie already about that subject. So that's something to think about. What I'd like to do is just to show you that there is a strong correlation between water poverty and Human Development Index. Well, in this case, what I've done is to tabulate the life expectancy at birth, again, a few years ago, against the Water Poverty Index. But I think you can see that there's an almost linear correlation between the improvement in Water Poverty Index and the improvement or increase in life expectancy. So again, over in Northern Europe, we expect to live to almost 80, and we have pretty good water supply, low water poverty. But on the other hand, down in Niger, you see that the average expectancy of life is 44. That's terrible. I didn't realize that. Most people die when they're born, but they don't live very long in that country. So as there might be expected, there's a correlation between the Water Poverty Index and other measures of development, such as the HDI. So really, you see how these two are connected. They come together, and that's really at the heart of sustainability, that all of these things are connected. They're not in isolation. They come together, and they have to be related. I'll talk a little bit about China, actually, because China is an interesting example of really what is not sustainable in terms of water. So this example is related to the Yellow River. Does anyone know the Yellow River? You've probably heard of it. I can't remember the name in China. I think it's Huangho, something like that. Does anyone speak Chinese? About 150 years ago, the river changed course. I think there was a very big flood, and it decided to go. It used to flow across, and then it moved to the north. But the point is that this river has a lot of silt. So it originates up here. This land here is quite mountainous. It's near to Tibet, very high, and the river's running very quickly. It's picking up lots of silt, and then it's slowing down and getting very big. And as it moves towards its delta, which is out here in the sea, the Bahar Sea, the river's slowing down, so this silt's building up. But of course, what's happening is the water's been drawn off for irrigation or for canals or other projects. And so in the last 50 years, the Yellow River has been drying up and silting up quite considerably. So both natural and man-made erosion, so that's probably caused by big ships or barges moving on the river, are causing the river to silt up. And at the same time, water's being extracted for development. What you find is that it's going from extremes. Sometimes you have very severe floods, lots of water moving down in a kind of hydraulic shock, which does a lot of erosion and damage. And there's other times where there's absolutely no flow whatsoever, so it's just dry, completely dry. So on this map you can see the main cities, you can see some hydrologic stations where measurements are made. There's tributaries and then the basin boundary. So that defines the basin boundary. You can see, as with most large river systems, it's a huge boundary. It's of the order of thousands of kilometers, very, very significant. So this is what happens when it dries up. So you can see here that this ship or barge is pretty much run aground. It can't get out. And this is all just very, very thick sediment. And some places you can measure the silt or sediment load, and it averages about 37 kilograms per cubic meter. So the water contains a great deal of sediment. Obviously, you can see why they call it the Yellow River. That's the color of the colloidal material or the clay that gives rise to the sediment in the first place. But in severe cases, it completely dries up. So this is another picture. What I'm plotting here is zero flow days. So these are days in the year where there's absolutely no flow in this river. And this is as a function of the year. And you can see that, in the early 70s up until the 80s, there were a few events, but not that often. But suddenly you get into 92. So this is the time when China relaxed, its policy relaxed. It became a much more open and capitalistic society, nonetheless a communistic one, but a very industrialized society. And you see that suddenly, bang, it's happening all the time. And then here you see, in this particular year, 97, there were more than 200 days in which the river wasn't flowing. So it's just not working anymore. They've pretty much destroyed the river. And this is clearly not sustainable. So how can we measure this kind of disaster? How can we sort of, we can say, well, it's not sustainable, but what do we mean? Well, let's use this as a kind of case study. So we need to have a sustainability indicator. And what we do is we define a river health index, which depends on the annual values of some of these variables. So what we look at is the length of the river over which there's no flow. So we can measure that as a sort of percentage of the whole flow. So that could give you one metric. Another one may be the number of days in the year in which the flow is too low to prevent sediment settling. So the river's moving too slowly in the longitudinal direction. There's more time for the material to settle, and eventually the silt will build up. How much water is actually available to the surrounding ecosystem to keep that running? How much water is available for socio-economic usage, in other words, for human usage, for utilization, including the potential for that. I mean, this poor guy trying to find water, but all he finds is this yellow mud. So we can put those together, and we can find a kind of composite metric. And the weighting may depend on what we decide is the most important. But nevertheless, at least we can measure that. That's the point. This is measurable. You've got hard, solid numbers, and nobody can argue with that because it's quantifiable. And this is the graph that we have. So I'm plotting this from 65 through to about 2000. This is when the study was done. So this chap, Borthwick, Al Borthwick, was my colleague at Oxford. He's now at Edinburgh. I'm not sure if you've met him, Eduardo. He's a hydraulic engineer, very famous guy. And you can see that, so this is the integrated index of river health. And you can see that in the 60s, it started off at 1.5, and there's been a kind of exponential decline with quite big variations. But by the year 2000, the index had dropped to 0.25. So there you have it. That's a single metric that measures the health of a river, and it shows clearly that the Yellow River is not sustainable in the present condition, but at least we have a metric to measure that, and that's what we need when we talk about sustainability. So let's open the discussion a little bit. I want to talk about some metrics that are used now by the UK government to measure sustainability. And what we do is we really group them into 4 areas. So one is to do with economics, economic benefit. One has to do with social equity, social development. One has to do with the environment or environmental protection. And the final one has to do with the efficiency of resources. So what we do is we have this almost, it looks like a sort of pie chart, but really it's a footprint. And each one of these spokes, the length of the spoke will depend on the size of the particular metric. So for resource, we have the resources that we use or how well we use them, how much waste we create. Down here in environmental, we look at the effect on things like the bird populations, fish stocks, river pollution, air pollution. Of course, we look at greenhouse gas emissions because that's very important for climate change. And we look at the quality of river waters we've just been discussing. So that's the environment. In this quadrant, we look at economic benefit. I've just mentioned economic output, but there's probably many, many things that you might want to look at there in that quadrant. Here, we have social development. And how do we measure social development? Well, we look at the well-being of the population. We look at environmental equality for people. They have equal access to a good environment. We look at social justice, mobility. We look at crime rates. We look at education, access to education. Pensioner poverty, so old people, do they have enough to live on? Childhood poverty, kids, do they have enough money to live on, or do their parents? Workless households, so households where the parents don't have any work. Health inequality, access to healthcare, access to employment, active community participation. So there's a lot of things that are used by the UK government to assess sustainability in a society. So here the 20 framework indicators used by the government are more closely aligned to a social agenda than the previous 15. So this is really a kind of a work in progress. It's still under development. But the current government's policy has 68 indicators. So I can probably leave a PDF of the files, but you do feel free to read around the, I think I gave you a reading list, right? You have the reading list? Or Mario has it? Yeah, there's a reading list. So you can, please do, I encourage you to read around the subject. You may forget what I've said, but there's a lot of stuff out there. So there's a good website on that. So this is just a study that was done on rivers in the UK. So they looked at, this is really how much of the rivers had been surveyed in the UK. So you can see, you can split the UK into Northern Ireland, England, Scotland, and Wales, and you can see that over the last 10 or so years, they've basically done more and more surveys. So the UK really getting into this sort of sustainability index measurement. So just to summarize the 3 areas that we need to measure in terms of metrics, we need to think about the environment, we need to think about the economics, we need to think about the society. So I think maybe we can have a sort of short discussion about this to try and open up people's ideas. I've written down some things that I think would be important as environmental indicators. So I've talked about how efficiently we use resources. So that's really what we take into the system. And this is really about what we do with it. So it's things like emissions, that might be gas streams, and then we have effluents, that might be liquid streams, and then I've got waste, which is usually sort of solid, but it can be different phases. And then I've got economic indicators, so the profits we make, the value of a project, the tax we pay, and the investments that are coming in. And then here I've got some social indicators, both in the workplace and in society. So there's probably, as used by the Institute of Chemical Engineers in the UK, there's about 50 indicators. But under each heading, there's scope for additional items. So you could think about, for instance, the money that's spent on research and development. It's a kind of, so the amount that's spent as a percentage of the profits or sales is a kind of indicator of investment. If you think about some of the big companies, I used to work for an oil company, and they probably spend about 0.5% of their profits on research. On the other hand, pharmaceutical companies spend about 15 or 20% because for them it's all about the next big drug, you know, the next big busting drug or whatever. So they have to spend a lot more money. But those are just some ideas. Shall we come back later and have a discussion about that, or does anyone want to make any suggestions? Have I missed anything out that seems blindingly obvious? Okay. But certainly those things have to be considered simultaneously, otherwise you're going to miss the story. Let's go on a bit. So this is the footprint of a process plant. So this was a study that was done on a processing plant, a little bit like the refinery that I showed you earlier. So they've looked at the four main areas. They looked here at resource efficiency, so which raw materials were being used? Did they use a lot of raw materials? How much was being recycled? So obviously, the less raw materials you have to use and the more you can recycle, the higher the index will be. So in this case, they have a score out here, and then here, this is the energy consumption. So do they use renewable energy as opposed to, you know, fossil fuel energy or something like that? So again, the more sustainable you can do that, the bigger that radius will be. And here you can see that they're not very good on land and water, so they're using lots of water. Process plants require a lot of water, and they require a lot of land, so it's not very sustainable from that point of view. But you can see that you start to get this kind of footprint. It looks a little bit like that. And here we look at environmental protection, so we look at gaseous emissions, liquid effluents and solid wastes, and you can see that they're not too bad on atmospheric waste or land waste, but very bad on aquatic. So this plant has a lot of liquid effluents, and it's obviously has a potential for contaminating river systems. Then we have on this side, we have the sort of economic benefits. So we have a reasonably good investment, but you see here that the profit and value isn't very good. So the problem is these days refineries don't make a lot of money. It's a very marginal kind of business. It doesn't have a very high added value. So here you have a poor added value and a poor margin. So you see that it's not doing well there. But what about the social benefits? I mean, we have to think about that as well. So let's look at the workplace. And when we think about the workplace, what do we need to look at? We need to look at the employees. Absenteeism, what does that really mean? It means that people are not showing up for work. Why are they not showing up for work? Because they don't like their jobs, because they're lazy, because they're alcoholic, they have health problems. But all of these are a kind of indication of how well things are working in that place of employment, because the more happy people are, generally, we find the less absent they tend to be, or the more well looked after they are, the more able they are to work. What about motivation? Are they getting the right kind of promotions to do their job? Maybe they get fed up because they think they should be in a higher level than they already are. What kind of salary do they get? What about the wages, the benefit ratio? So you look at the top 10% of the people relative to the bottom 10%, you probably find that the top 10% earn 10 times as much as the bottom 10%. So the management directors earn a lot more money than people who sweep the floor or something like that. It's very unfair, but it's a recipe for unhappiness. But it's also a recipe for motivation. So difficult thing to analyze, but it's an important one. So we look at the workplace, we look at society in general. Now, if you have a very large plant like Stanlow in a small town, it may be the major employer. I'm not sure what the major employer is in San Carlos. Apart from the university, you have the TAM base here, and there's quite a few fazendas.
TAM, Electrolux, Tecumseh, industries, big industries. Maybe your Faber-Castell.
Faber-Castell, yeah. Mm-hmm. And they make these
pens
and pencils. I remember, yeah. So you could probably draw a diagram like this for San Carlos and try to work out what the footprint is. And this shape is quite typical, actually. So you find that generally it's doing quite well socially, not so well in terms of resources or investment, and then it's a mixed bag in terms of environment. But what we want to do is stretch this out into the biggest circle that we could possibly make. So I think this may be a useful tool for you to use when you come to analyze a particular project. Now, there's a problem with measurements. We all know this, that we can massage them. So we want to have a metric that we can measure performance against. And that might be a measure of sustainability. Or it might be, for instance, a university ranking. So you take a university and you rank that department against other departments in Brazil. So, for instance, your Department of Engineering at USP compared to Florianopolis, compared to Recife or somewhere like that. I'm sure you all look at these figures. That's maybe why you came here. But once you have a measure and it becomes a target, in other words, that's really what you're trying to manipulate. You know, the people behind that are trying to change it to make it better. Then it ceases to be a good measure because it's being somehow corrupted and changed. And that's not a good thing. This was a statement that was made. It's Goodhart's law. He was a professor working at the London School of Economics. And what that shows is that no system is perfect, but the danger of having metrics and measurements is that they're open to manipulation. You can massage data, you can make it look good. That's particularly what politicians try to do when they're looking at health data, so the performance of hospitals, the performance of schools, and so on. But the point is that even if you massage the data and meet the target for one particular indicator, it does not mean that some other aspect becomes significantly worse. So you can't target one indicator at the expense of others. It has to be all. So think about the footprint. It's no use having one corner doing very well. It has to be all the corners of that diagram. And that means we need to have composite targets. So that's what I've been talking about, having targets that are made up from many different variables that come together, because then it's too difficult to manipulate them. So we need to have composite targets and composite indicators. Okay, we're coming to the end. So let's go back to Lord Kelvin back in 1883. Remember what he said? I often say that when you can measure what you are speaking about and express it in numbers, you know something about it. But when you cannot measure it, when you cannot express it in numbers, your knowledge is of a meager and unsatisfactory kind. Now that's a very quantitative way of looking at the world. I'm sure that people who work in humanities and social sciences may disagree with that, but as physical scientists, as engineers, that's very important to us. It's the only way that we can really measure things. And here's some sort of closing ideas. The water debate, I hope I've shown you that it's just as crucial to achieving sustainability as the energy debate. In fact, in my lecture this evening, I'm going to talk about water and energy and food and how they interact. So the provision of safe water, we know clean water, adequate sanitation, necessary irrigation, all of those things are going to be vital if we are going to achieve this overlap in the middle. But the good news is that quantitative indicators can help us to monitor and direct the improvements. So I'll just summarize the statement from Brundtland. Sustainable development is development that meets the needs of the present, so that's us, without compromising the ability of future generations to meet their own needs. So I think that's the first take-home message. So remember that, and then the second take-home message is what Lord Kelvin said. Just acknowledge some people, so I'm going to acknowledge Al Borthwick, who did a lot of the work at Oxford. Now he's moved to the University of Edinburgh. And then there's Roger Booth and Roland Clift, who works, and this guy, Adisa Azapagic, it's a Turkish name, who's working at the University of Surrey. So all of those people are doing very important work now on sustainability indicators. And it's very good work, so do have a look at that. And that's the end of the lecture. So I think we have, do we have time for some discussion? Or
we can have a coffee break first.
Yeah. Quite a long time to listen to me, isn't it?